Okay, so hi everyone. So welcome in our data analysis using R programming course. And in our today's session, we will cover about introduction to R windows and I will use R as a calculator part. Okay, so I'm just sharing my screen and show you different windows is already being open in front of you. Okay, so I will introduce one by one windows and how you will manage all those windows so that you can completely understand what these windows are and how you can take or you can understand the purpose of all those windows. Okay, so here we are seeing that our R studio is divided into majorly four screens. Okay, here four screens you are able to see. So this is the one part, this is the one part, this is the another part, and this is the fourth one part. Okay, so each part has their own properties. Okay, each part is having their own functions. Okay, what they are having and what the rules and responsibilities these all are having. Okay, so the first part is basically called as notepad. Okay, this is basically a notepad editor window. You can say that this is an editor window. So what it means by editor window? So editor window means where you will write all your code. Okay, so like for example, if I will write a program, simply print, okay, hello. Okay, so this is simply a code I had written over here. Okay, so in this particular place I will use this as a notepad. Over there I will write all my codes. Okay, and I will save this particular program, okay, this particular notepad, so that in future if I wanted to utilize this particular line of code, okay, so I can easily get it back. Okay, so this basically part is just for writing your code. Okay, and in this code will be stored with the file name as some file name .r extension, and since currently these all files are not being saved, that is why these files are named as untitled. Okay, so if you wanted to save, you can just go through over here and you can click here save as. Okay, and you can save it into some specific places. Okay, so this is an introduction about this particular window. So in this particular window you are having multiple things. So like for example, here you can see two buttons are there, one is run, one is rerun. Okay, so this part is just telling you about that whatever the things you are writing over here. So like for example, currently this line is written, I wanted to run this particular line. Okay, so I will click over here run. Okay, so automatically you will say this particular line is being run. Okay, now here is the output coming. Okay, I will come back to this particular part, what this particular part is telling to you. Okay, now here suppose I wanted to go back and rerun the previous code. Okay, I can run it again. So like for example, my cursor is blinking over here, but I wanted to run this particular line of code. So if my cursor is over here, then if I wanted to run, I need to click into the run part. But if my cursor is below here, okay, and now I wanted to run the previous code, so I can click over here so that I can able to run the previous code as well. Okay, so here it is showing you the source. Okay, the source, the content of the active document. Okay, so currently it is showing that this basically part is storing into this particular place like active.rstudio documents. Okay, this is basically called as the source document. Okay, I'll tell you that what exactly meaning of source document in our coming classes. Okay, now this is the introduction about our first editor window. Okay, now once you are running this particular program, okay, so first thing I wanted to tell you about the difference between compiler and interpreter. Okay, so I just told you that in our previous class that just to understand about compiler and interpreter. Okay, so if you understand this part, okay, that is perfectly fine. But if you are having any doubt or any question, maybe I can quickly try to cover this part to you. Okay, so compiler means just to take the code, whatever the code is being written, just to take a whole code and convert this code into the machine language so that machine can understand about the instructions. Okay, and once machine will understand the instruction, according to that it will process this particular code, and after processing it will give back to you the output. This is called as compiler. This is the process, this is the use of compiler. So in the compiler what we are doing, we are passing all our code at a once. Okay, so like for example, if for solving a particular problem we have drafted 1000 line of code, maybe, okay, it may be 1000, it may be 500, maybe 200, maybe 100, whatever it will be, right? So depend on the size of the line of codes, okay, it will go once in the compiler, and all those codes is being compiled, kind of converted into the machine language and converted into the instruction sets, and based on that, after processing, it will come back again as a output. This is the role of a compiler. There is a problem in compiler is that if there is a problem in a one line, at least one line, okay, so the whole code will show you the error. Okay, whole code will show you the error. It means that you need to go through each and every line just to find out the error, so that whole program can able to run it, right? It means that you are working with a complete box. Okay, so if some error is there, you need to kind of identify the error in the whole box only, right? But it is very difficult. It is very difficult. Now you move ahead for the interpreter part. So interpreter part is basically tells you about that when you wanted to run your code line by line. Okay, so like for example, for solving a particular problem, you drafted 100 line of code, so you will run all your code line by one line. Okay, so like for example, I had written over here, I will run it. Okay, I will run it. Okay, this program automatically be run. Now it will move to the line number 2. Similarly, it will move to the line number 3, line number 4, line number 5. So in which line the problem is, it will easily it will be easily identifiable, right? So if we identify any problem, we will take care of that on that particular line only. No need to run all those codes, debug all those codes. Okay, so this in this way compiler and interpreter are different. So as I told in our introduction classes, that R is basically based on a interpreter based language. Okay, so because R is designed from the S language, and S language was based on the compiler base. Okay, so this is the enhancement happened into the R programming language, and this is the one of the most beautiful thing into the R programming. Okay, so now if I now this part is hopefully this part is clear to you about the difference of a compiler and interpreter. Okay, now this part is just a writing a code over here. Okay, now once you using the interpreter, if you run this particular code, now this part will go into the interpreter. Okay, so interpreter will convert this particular part into the instruction set, which is called as machine language, so that machine can understand, and it will process, and it will give the output according to the instruction set to the machine. Okay, so where I will see this process, so once I will run this process, then I can see that this code is going to the interpreter, where I can see into the console window. Okay, so this is another window into the R Studio, which is called as console window. Now this console window is what? This console window is basically showing you the footprint of interpreter. Okay, so like if you see here, I just ran this particular line of code multiple times. Okay, so I can track all those records, that how many times I just ran this particular code. It means that firstly this line enter into the compile interpreter, and interpreter will just take this particular thing as an input and take as an instruction set, and according to that it process and give us the output hello. Okay, so here this is our code, and this code is go to the interpreter and converted into the output, and output is coming below this. Okay, similarly this line of code is again passed into the interpreter, and this output is coming. Similarly this code is also going into the interpreter, and this output is coming, right? So where we can see the activity of interpreter, we can see the activity of interpreter into the console window. Okay, and you can also tell that in console window we can see what the code I had run and what the output I am getting. Okay, so this part I can see into the interpreter part, right? Similarly in this particular window, okay, as you are having run, we have run previous, we have source. Similarly here in this window we also have three things. First is console. Okay, in the console part, as you understand that in the console part we are having our codes along with their outputs. Okay, so which is run already into the interpreter part. Now the second part is called as terminal part. Okay, so terminal part is basically tells you about that if you wanted to connect your system with any external repositories. Okay, so you can create a terminal window over here, right? So in the terminal part, usually we create our repository like maybe in GitHub or maybe any other version control tools. Okay, so in the terminal part we will able to interact with them. Okay, so terminal is basic like what we are having in our machine, which is called as PowerShell. Okay, so in the PowerShell terminal we are connecting with our device to the external sources. Okay, maybe some external repositories, maybe some external databases. Okay, so this PowerShell is basically a connection established method. Okay, based on that we will establish our connection with the outsource thing. So similarly here in the R Studio, this part can be handled by using our terminal. Okay, so terminal is just used for establishing a connection between this particular R environment to the repositories, external repositories like GitHub, like GitLab. Okay, maybe some other repositories are also available, like AWS is available, Amazon Web Server is there, Azure platform is there. Okay, so we can connect those things from here only. Okay, and also we do have background jobs. Okay, so there are so many jobs which are running into the backgrounds. Okay, so this job is visible to over here to you. Okay, so this is an introduction about this particular window. Now let me move to the third window. Okay, so this is the third window, and in the third window what the things are there. Okay, so in this window you can see there is a majorly four parts are here. One is called as environment, another is called as history, another is called as connections, another is called as tutorials. Okay, so let me introduce you about one by one to each and everything. Okay, so environment is basically as I told in our first class, environment is nothing but it's a set of objects. Okay, and data types. Okay, and data sets. So whatever the things we are creating into our code. Okay, so like for example, if we create a variable, if we create a data set, if we create any functions. Okay, so all those things are combined together, and these things together called as environment. Okay, so like our environment is there. In our environment what are the things are? So like we have our house, we have our vehicles, we have our maybe food things. Okay, food and grains, we have our home. Okay, so different things are there in our environment. Okay, similarly in our environment what are the things are there? We have data sets, we have variables, we have functions. Okay, so those details, those are things combined together as called as environment. So like for example, suppose let me create a variable. Okay, a is equal to 2. Okay, so a is equal to 2 I assign, and you can easily see that here automatically a variable is being created, and this a variable is having value 2. Okay, so I can easily understand these things from the environment. Here I can see this code I had written. Okay, this code I had written, but we can see this part into three places. First is this is our code window. In the code window I can see, and this is our run window console. Over there I can see this into the running mode. Okay, and this window, this is called as environment. Here also we can see this as a variable name. Okay, since this is the environment. Now in the environment we do have multiple things like import data set, we are having global environment, right? So there's a different environments are there. Okay, so this is basically selected as a global environment. Here you can say we have drop down menu like R and Python. Okay, so whatever the environment I wanted to set. Okay, so all those things can be visible over here to you, right? Similarly you have another window, okay, which is called as history. Okay, so history is basically creating a history itself. Okay, what it mean by history? So whatever the activities you will do into your R programming, into this particular area. Okay, in this editor window or in this particular console window, if you run any code, anything. Okay, everything will automatically comes into the history part. Okay, so like for example, I ran this print code multiple times. You can easily see that this code is running today. Okay, these 4 5 lines are being automatically run in today's class only. Okay, so these things are visible to us into the history part. So suppose if you delete something, like for example, suppose it is deleted by me. Okay, let's suppose, and I wanted to uh, revoke it. Okay, so what I can do, I will just click over into this particular line, and I will write it. I will click over here to source. Automatically see one line is going there. Now maybe again I want to do the same line. I will write it over here. I will just click. Automatically those things are coming over here, because these things are already available into our history, so that I am just recalling it into our in this window, because this window is already being deleted, maybe someone deleted, okay, and I wanted to again revoke all those changes. So I can go here and just click onto the to source. Okay, there's a one window is one option is showing here, to source. Click over here, automatically this line of code will move here, right? Now if you wanted to suppose histories, because history is also taking so much space, and if you wanted to delete this particular part, wanted to release the our RAM, so that our big data analysis can be easily performed. Okay, so you need to just clean the history after some time. Okay, if you are thinking that whatever the things are available, these things are already being saved, now you wanted to clean all those things, so always try to clean your history. So just to clean those things, you can click into this part, and without saving histories, just to delete it. Okay, yeah, now this part is deleted. Okay, so this is all about history part. Now we will move towards the connection part. So as I told, we will establish the connection between the databases. Okay, from the different databases, like we can easily connect with the different cloud based databases, we can connect it with some local machines. Okay, so from here we will establish some connections, right? Now here, this is the most important part of this particular session, is tutorial. Okay, R is itself providing you a very enhanced syllabus. Okay, very elaborative syllabus. Okay, you can easily learn everything from here, right? So whatever the things you wanted to explore, you can always reach to this place. Okay, and you can start exploring the concept. Okay, where you will go? Okay, I will tell you that where you will find different contents. Okay, so like for example, here you have R Studio tutorial powered by LearnR package. Okay, so if you click over here, automatically that you will land up into a page. Okay, and over there you will see that all those R Studio trainings are easily available. Okay, but now the question is, why you are connecting with me then, if everything is available into the software? The problem is that everything is available into the software itself. Whatever the functions I will tell to you, everything is already available into the R Studio trainings. Okay, everything is available, but sometimes you will not able to understand those concepts, and you will not able to understand which is very important for you and which is not that much important for you. For that thing, we are connected here as a training sessions. Okay, for that thing I am actually teaching to you guys. Now coming to the fourth window. So the fourth window is basically introducing you about different sub windows. Okay, first is files. So like for example, currently all those things which is visible over here, this is basically my file, my directory details. Okay, so this is all about only where your system is being installed, all those things are being visible to you. Okay, now coming to the plots part. Okay, so plots, so for example, if I will create any plot over there, like for example, let me give you a very small introduction about plot. Okay, okay, so see here, a plot is coming over here, right? So in this area, in this particular area only the plot will come. Okay, so if you wanted to download this particular plot, okay, you can export those plots into different versions. Like for example, you can store your plot into the image format, maybe jpeg, maybe jpg. Okay, similarly you can store your plot into the pdf file. Okay, or maybe you can copy this plot into your clipboard. Okay, so for example, I wanted to paste those things into our Microsoft Word part, or maybe in any of the thesis I wanted to include this part. Okay, so I will just copy to clipboard, and from there you can take it into our document. Okay, so in this part, the only part I wanted to explain is, in this part you will always just um, uh, you will find the your plots. Okay, your analysis plots. Okay, you can zoom this. Okay, in this way you can zoom it, so you will see that this plot is automatically in the bigger size coming. Okay, so whenever you wanted to move to the next, okay, always try to close it. I guess any question come into the group? Yeah, please, maybe Georgia, if you have any question, maybe you can ask.
Yes, thank you very much. Please, I have seen that when you run the code on the histogram,
uh,
that histogram that you had, is it an inbuilt-in?
Sorry, maybe George, I missed your question. Could you please come again?
Uh, the code number 3 that you ran,
Uh-huh, yeah.
the hist bracket open R num bracket.
Yeah,
thousand, then double bracket.
yeah, yeah.
Yes, that particular code. Does it mean that anytime we type something like that, we are going to see the histogram in the plot?
Yes, yes, yeah. So yeah, so it depends. Like for example, this is the command I just wrote it over here. Okay, so I just wrote just for your demonstration purpose, that just to demonstrate that where our plot will be visible. Okay, so this part, maybe this is basically a visualization, data visualization commands. I know this part, so I directly just for your understanding, I just created this plot. So basically this command is tells you about just to create a histogram. We have a very good command into our software called hist. Okay, so in the hist command we need to pass whatever the data we are having. You will, if you pass any data point over here, automatically you will create a histogram for this particular data. So currently what I am doing is I am just generating few numbers. Okay, I am just, because I do not have data to me. Okay, so I will generate artificial data, okay, which is called as simulation. Okay, so I am just generating the data from a very established method which is called as normal distribution. Okay, so from this distribution actually I'm generating the data. Like for example, see here, so many data is being generated from this particular command. Okay, r norm, and this is 1000, so it is giving me 100 data, 1000 data points. Okay, and based on this particular 1000 data point, I just created a histogram. Okay, just for a demonstration purpose. So this part I will cover in a much more details to you during our actual content session. Okay, once the introduction will done, I will explain those parts in a much more details. Okay, perfect. Now, so let me move to the third window, which is called as packages. Now this is a very important part which you need to keep in your mind. Okay, so this package part is basically tells you about two things, like whatever the packages available into your machine. Okay, so like for example, as I told in our previous class, that R is providing you a wide variety of base functionalities, that if you install R Studio into your computer, so many functionalities you can avail. Okay, so R is itself coming with a very rich functionalities. But even though, if suppose you are working in any specific domain, and over there R is not having so much functionalities. Okay, so what you can do, you can develop new things. Okay, you can develop new things, and which things are called as packages. Okay, which is called as R packages. So for example, suppose if someone is working into the survival analysis, if someone is working onto the longitudinal data analysis, if someone is working onto the spatial data analysis, if someone is working on the biological data analysis. Okay, so at that time you have a very established packages into our R programming. Okay, so like for example, here if you see, so many packages are there: string I, tibble, tidyr. Okay, so these broom package is there, Jew package is there, right, cluster analysis is there, methods is there, stats is there, utils is there. Okay, survival analysis for this survival package is there. Okay, okay, so I guess screen is not visible. Okay, maybe, yeah. Okay, so I was onto the packages part. Okay, so I was just explaining that along with the base functionalities, we do have so many external packages. Okay, so all those packages are being listed over here. Okay, so this is basically a library. Okay, this is basically a package library. Let's suppose these are the books, and which books you wanted to read. Okay, it means that for the what are the functionalities you wanted to utilize. Okay, so those functionalities you can utilize by selecting over here check. Okay, so if you check over here, it means that it automatically being installed into your computer, and your machine will start using these particular packages. Okay, so I will come and explain those parts to you. Okay, now coming to the other window, which is called as help window. Okay, so help window is basically help, try to provide you the help. Okay, so like for example, if you stuck at any places, okay, and you wanted to search the command. Okay, so based on this particular help part, you can explain, you can get an explanation about those things. So like for example, suppose if I write it over here like mean. Okay, so it will tell me about different types of means. Okay, so like for example, here you will see, sorry, maybe here I will explain mean. See here, so automatically if I type it over here mean, so a big detailed document is coming to me. Okay, so I can easily run those concept, those details, that what exactly mean function is doing. So like for example, it is telling that mean, this is the mean function is available into our base package. Okay, and this is mean is basically working on the concept of arithmetic mean. Okay, you know that there is a different types of means are there, like arithmetic mean, we do have geometric mean, we do have harmonic mean. Okay, so this is basically taking arithmetic mean as a output. Okay, so basically this is a generic function and trimmed arithmetic mean. Now how you will use it, it will give you like mean, and you need to pass a data set over here, data vector over here, and you will use this particular part, and here is the explanation of those parameters. Okay, and here is the some values. Okay, some values they have already been set up, and from where this particular command is being developed. Okay, and after that it will show you some examples. Okay, run examples. So if you run these examples, automatically you will see over here like mean of this data. Okay, xm mean of x, it means that it will automatically show you that how you will run the code. Okay, so let me come back and show you some examples. So see here, x is a data set. Okay, this let's suppose I will just take this data set over here. Okay, I will run it. Okay, now I can show you that what are the things available into our x. So you can see in x we do have data like this data we are having, right? Now if I wanted to calculate, so I can use the mean functions, and this mean function can take this particular data and it will give me the average of this particular data variable, right? So the average of this particular data values is nothing but 8.75. Okay, in that way I can calculate the mean, right? So not only mean, okay, you can take help of anything. Okay, so like for example mean, okay, or maybe any specific packages like maybe substr. Okay, so maybe you can type it. Okay, substr just for string things. You will see so much details are there. Okay, so like for example substr path functions, substring path functions. Okay, so many functions are there. Okay, so maybe in our coming classes when I will taught you about different functions. Okay, so at that time you can if you missed anything, if you are recalling a very small functions, you can just type it over here and you will get a very rich details from here, right? So in that way you will able to take a help from here. So this is a very great portion of the R Studio software, that you will always have a ready to use functions details and their explanations, right? Now here we have the viewer part. Okay, and here we have the presentation part. So suppose if you are creating any presentation and you wanted to present the things, okay, you can create a presentation from here and you can present this presentation in any of the places, right? So this is the introduction about this particular software, R Studio software. Okay, so I hope it is clear to everyone, but for sure let me take a pause. If anyone have any questions, maybe we can discuss now. Anyone? Yeah, please George, come again.
Okay, so thank you very much. Uh, I want to find out with the example when you were teaching us about how to find the mean. After the first line, that is s is less than minus c. Why the c? That is the first question. And then why do we have to write s after that line before coming to the mean?
Okay, so this part you wanted to tell? Maybe George, sorry, come again. Actually, I missed your question. Please, sorry, come again.
But the same part. That's it, where you have highlighted. I was asking why do we bring c after the s is less than minus? See, we have some
Okay,
c
okay,
there
yeah, yeah. No,
before.
I'll tell that part. I'll tell that part. No problem, because this is a introduction part. I'll tell you that what exactly we are writing over here. These are basically like we are having English grammar, we are having our language grammar. Similarly, every programming languages has their own grammar. Okay, some set of rules. So I will tell those parts. Okay, no worries at all. So this is not a less than or minus symbol. Okay, this is having their own definite meaning. Okay, I'll come to that part. I'll explain that what exactly we are writing over there and what the meaning of those things. Okay, so this is basically a programming
Okay.
style. Yeah, this is basically a programming style. Okay, so I will tell you maybe in our coming classes you will able to understand that part. No problem at all. Okay, Perfect. So okay,
Thank you
so
very much.
yeah. So this is the part. Yeah, I'm coming to that part. I'll explain those parts in a maybe coming session in today's, or maybe in our next session. I will explain those parts in a much more detailed way. Okay. Now coming to the license part. Okay, how you will understand what's license we are having now. Okay. So just a command.
Hello,
Yeah.
hello, Doc.
Yes, Richard. Yeah,
Doc,
yeah,
please,
Richard. Go ahead.
before you start with the license part,
Mm-hmm.
I want to ask a question. You wrote a code
Mm-hmm.
like is it H into brackets, then
Yeah,
then yeah, that code,
yeah,
then thousand, and then you had a graph, a
yeah,
histogram graph.
yeah.
Is it that you've already downloaded the what do you call it, the data? Because I'm trying to also use the same code the way you wrote it and then everything. I'm not getting the graph.
Okay, yeah. You can always get the data. Like for example, what the data is being used to just create this particular visualization. Okay, so you can get it like the data is basically here. Okay, so this is the data part. Okay, so I'll take it out this command. See here. Now this command is basically used for data. Okay, so you will just create a data set, data variable name A. Okay, in A variable you will store the data set. Okay, so in if I will just run A over here, see this is the data set, data we are having, right? So in that way you will see the data. Okay.
All right.
Yeah,
Thank you very much.
yeah.
Thank you.
Hi Joseph. Yeah, please go ahead.
Please, I think I want to help my brother. My brother, please click on the plot. Probably you didn't click on the plot. That is why you didn't see the graph.
Yeah.
Okay. All right. Thank you very much. Thank you.
Okay. Now, perfect. So let me move towards the next part. Okay, so the next part is just to tell you about some basic functions over here. Before we start going too deeper into the R programming part, let's understand about its license part. Okay, so license, basically, if you know the license of any programming language, then it is very good because it is telling you about many more details. Okay, so like for example, this is basically tells you about many details. Okay, so it will tells you about the package, okay, and which GNU license this particular product is having now. Okay, so this details basically is coming into the license part. Okay, like this software is distributed under the terms of the GNU general public license, either version 2 June 1991 or version 3 June 2017. The terms of the version of the license are in the file called copying, which you should have received with the this software and which can be displayed by RSODoc. Okay, so maybe I can just quickly show you. So if I will run it over here, this part, so you can see here very detailed terms and condition are being written over here. Okay, but since this is a freeware software, you know that if anything is freely available into the GNU license, this is perfectly for the user, right? Okay, so no need to go much more details, and don't do not to learn any each and everything from here. But yeah, definitely you should to understand that what are the things are there into our license part. Okay, so if you wanted to learn about the license, you need to remember these two commands with you. Okay, so now coming to, suppose if you are working into your data analysis activities, or into your research paper or research article. Okay, so at that time definitely you know that you need to give the reference, you need to cite the things. Okay, you need to quote the things, you need to provide the feed in the note, footnote. Okay, whatever the things are there, everywhere you need to create a citations. Okay, so if you wanted to give a citation into your manuscript, okay, so how, what the things you will write over there, this citation part you can extract from here, like citation. Okay, click over here and you can see that this text is coming like this details you will take, and you will include this part into your manuscript as a citation part, right? So this is the way how you can cite your software, because software cite is very much important when you are publishing any result by using your data analysis. Okay, so you need to publish all those things, and then provide these details to the into the manuscript, so that whoever is the reader of this particular manuscript can understand that where this analysis is being done. Okay, and how this analysis is being done, every details will be there under this particular citation part. right? Now suppose everything is good, perfectly fine. Now I wanted to close this software. Okay, so I will use a very good command called q. Okay, where q is basically tells you about quit. Okay, so if I will click over here, automatically it will ask me that if you wanted to save this workspace, because this is the one workspace is being open to me. Okay, so if I workspace means from where I am working. Okay, so if I wanted to save this, I will write yes. If I don't want to save this, I will write no over here, right? So if I will click over here no, automatically it will be deleted, right? Now I know that maybe my screen is going for you. Okay, because this screen is going, just because of that I just quit my R Studio software and my screen was visible only for the R Studio part. That is why this is not visible to you. Okay, so let me again open this screen in front of me. Okay, and start telling you about some other commands. Okay, so I'm just sharing my screen to you again. It is loading basically. Okay, so like for example in any of the programming. Okay, so if you are doing any programming in general task. Okay, if you are doing anything, so you always give a message. Okay, so that whatever the task you did, like for example if you are creating any notes into your pen and paper based theory. Okay, over there if you are doing anything, you are just explaining that what the things it is. Okay, so let me tell you what I'm talking about. Okay, perfect. I hope my screen is visible. Okay, now what I am telling is, so like for example suppose multiple things I had written over here, right? But let's suppose someone is not understanding this, why this license command, what this license command is doing. Okay, so I will just give a hint to everyone. Okay, so that user can easily understand that what the command I had written below, this command is doing what. Okay, so for that thing we always use a one method which is called as commenting. So this is the one very important part of a programming which is called as good programming practice. Okay, just follow the concept of good programming practice. We are doing some very important things. Among them first is called as commenting. Okay, so commenting is a method. Based on that we are providing a small hint to the user, okay, or the developer, so that anyone can easily understand about this particular command and whatever the task you did in this particular code. So like for example suppose this is our session 1, session 2. This is not 1, this is session 2. Okay, so this is the one comment I had given over here, and this is the comment. Okay, maybe showing the command for getting license details. Okay, so whoever is the reader of this particular code, okay, they will easily understand that below this particular comment whatever the things is being written. So this is for what, it is just for use as just showing the comment. Show you the command, show you the command for getting license details. Okay, anyone can easily understand. So for that thing commenting is very much important, because in general what is happening, like when we are doing any data analysis activities, we are writing thousands line of codes. Okay, this is not only that we are writing only 10 20 lines or 1 or 2 lines. Okay, so we are just for doing one analysis. Okay, you are writing thousands line of code. Sometimes if you are doing a very big data analysis, at that time you are writing a huge chunk of codes. Okay, so so that anyone can easily understand this particular code, you need to give a proper comment. Okay, so that anyone can easily understand what this comment is for. Okay, so how you will give the comment, so into the R Studio software, in R software everywhere, just for using a single hash symbol. Okay, by using single hash symbol, whatever the things you will write in front of it, this will be called as comment. Okay, so what is the beauty of this particular hash symbol is, so whatever the things you are writing just after the hash symbol, this is not going into the interpreter. Remember, whatever the things you are writing in front of hash symbol, this is called as comment, and this comment will not go into the arc interpreter. Okay, it means that this will not run. Okay, because this is a simple message, no need to run this particular message. That is why you will utilize the hash symbol before this particular line, so that this line will not enter into the software and this line will not run. Okay, unnecessary, it will not take the memory. So everything, every time you need to use the comment thing. Okay, whatever the doing things you are doing, always use the comment, so that you can, after some time when you wanted to revise your code, you can understand about the comment part. Okay, now how do you comment on multiple lines? Okay, so suppose if you wanted to do the comments on a multiple lines, okay, so what you can do, just to place again a hash symbol. Okay, in how many lines you will place the hash symbol, it will take the comment as whole. Okay, so like for example, comment 1, this is for comment 1. Okay, and now this is for comment 2, comment 2. Similarly, this is for comment 3. Okay, so how many lines of comments you wanted to give, you can include in this way: comment 1, comment 2, comment 3. Okay, in that way you can do it. Perfect, right? Okay, now further things, what are the important thing you need to remember, right? So this comment part is the one thing. Okay, the another thing is that ls. Okay, so ls command, so this is basically a function. Okay, so this function is basically used for checking the that what are the environment thing is. Okay, so like for example, if suppose I just run this particular code. Okay, let me run few things over here. Don't bother about this particular thing what I'm doing over here. I'm just showing you few things. Okay, so that you will understand this part. Like for example, suppose I just created two variables, a is equal to 2 and b is equal to 4. Now these two things are being taken into the environment as well, right? So now suppose if these two things are being deleted. Okay, now I wanted to see that what other things is available into our environment. So just to check the environment things. Okay, checking the environment details. Okay, you can use the functions ls. Okay, so if I will place over here ls and I will run it. Okay, just for running you will use this command. Automatically it is showing me that there are two variables is being created over here. Okay, so first variable is called as a and second variable is creating as b. Okay, now two things are available into our environment. Now suppose if we are no if you wanted to don't want to use this a or b, we can remove it, because whatever the things is available into the environment, these all things are taking the space into the memory, right? Now suppose I wanted to delete some of the things from here, so there is a very good command is available. Okay, removing the environment. Okay, environment variable. Okay, so what I will do is I will use the command rm. Okay, so rm is a command. Rm is basically a function. Okay, which if you pass anything over here into this, okay, it will remove it. So like for example, here a and b is available, I wanted to remove the a. Okay, so I will type over here rm in bracket a. So okay, it will automatically delete the a. See here, a is being deleted from here. Now suppose I wanted to delete the b. Okay, so I will delete the rm and b. See here, environment is automatically being cleaned. Right now nothing is into in our a environment. Okay, now if you in that way you can remove one by one. Okay, in that way you can remove one by one. Now let's suppose you wanted to delete all environment things in one go. Okay, in one go I wanted to delete. Okay, so like for example, suppose a is equal to 4 we are having, b is equal to 5 we are having, and c is equal to 6 we are having. Okay, so three things are available into our environment, right? So if I wanted to delete all those things together, right, so what I will do here, I will use the command called rm. Okay, in rm function I will write the command like list is equal to ls. Okay, so list is equal to ls I will write over here. Okay, so list is equal to ls, basically just ls command, you know that ls command is just used for showing that what are the environment variables are. Okay, so in the environment we are having three things a, b and c. Now I wanted to remove all those things, I will create a list for that. Okay, list is equal to ls. Okay, so in ls part, okay, I'll tell you, George, I'm coming to your part. So I will just use the rm command. Okay, so in rm command I will write in this way, and see automatically all those things is being deleted from here, right? Rm list is equal to ls. Okay, perfect. Now few questions are coming, so you can come here, which is called as view. Okay, into the view window you are having panes. Okay, so in the panes window, if any of you are not able to see all four panes, okay, so you can click over here panes and show all panes, right? So if you are just click into this, automatically you will able to see all those panes over here, right? So in that way you can find it, George. Okay, perfect. Now these are the two ways. Okay, first is ls is just used for seeing all the variables which is available into the environment. This will list out over here. Since right now nothing is available, okay, that is why this is not very much clear to you maybe. But after some time, when you are comfortable with doing the programming, at that time when you do the data analysis activities, at that time you will create thousands of variable. Okay, sometimes you are just doing a survey, you wanted to store your data set over here, so your data set will have so many variables. Okay, so all those things will be created automatically into the list. There will be a huge list. Okay, huge environment list is there. So if you wanted to find anything, you will always check the ls window. Okay, ls function, and using the ls function you can see whatever the variables are available over there. Now if you wanted to remove one by one variables, always use rm command, and by using the rm things you need to you can delete the any of the environment variable. Now question is definitely question should come into your mind, is that why we are removing the things. Okay, because you know that if you remove the things, okay, it will automatically be erased from your memory. Okay, you erased from your ram, and you know that ram is very limited. If you have a very good ram for your software to run, okay, your program will run very efficiently. For that purpose, if any unnecessary or unused things is available into your environment, you can delete it so that this memory can be reduced. Okay, this can be memory can be released, sorry, not reduced, this will be released, so that you will have a sufficient memory so that your program can efficiently run the codes. Okay, for that purpose we are removing the things. Now suppose if you're done with all the analysis, now you wanted to clean the environment. Okay, so you can use this particular command like rm. In rm function, okay, in rm function you will write list is equal to ls. Okay, using the list is equal to ls function, okay, ls parameter, you will delete all those important parameters from this particular environment. Okay, so these are the few things you need to keep in your mind. Okay, now next topic is prompting. Okay, what it meant by prompting. So prompting is basically tells you about that, like for example this greater than symbol you are written over here. Okay, this basically greater than symbol is called as prompt. Okay, so prompt is nothing but that, just an indicator that something is coming here. Okay, prompt is nothing but it's just a thing which is telling you that there is something will come over here at this place. Okay, for that purpose prompt is being used. Okay, so you can change the prompt as well according to your use. Okay, maybe let's suppose I'm liking this particular symbol. Okay, I'm using it. Okay, but someone, let's suppose you wanted to use some other type of prompt. Okay, you can use the options. Okay, there is a one command is available which is called as options, and under the options part you need to write prompt. Okay, you need to write prompt, and in the prompt, in the double quote, okay, everything you will write into the double quote prompt. Maybe I wanted to run r in brackets greater than symbol, right? So now you see here automatically r and greater than symbol is coming, right? I'm liking this part, that is why I just given. Okay, maybe you can do it as per you. Okay, maybe you can place your name and this command. Sometimes it is important, sometimes it is not important. Let's suppose if you are in an academic and your teacher wants to see your name in your maybe commands. Okay, at that time what you can do, maybe you can save your name. and give a name over here, like for example name. Okay, and your name with this particular symbol will come over here, right? So whatever the things you will write over here, it will come with your name, right? So this is just for decorating your R commands. Okay, nothing else. This is not for any specific purpose. Okay, no need. If you don't want to set it, no problem at all. What is the things is coming by default, this is perfectly fine. Okay, so but if you wanted to change the prompt, you can change your prompt using this particular function, which is called as options. Inside the options you have a prompt is equal to, okay, and you need to specify in prompt is equal to double quote whatever the things you will specify over here. This will come into this particular window, okay, and in front of that everything will be run now, right? So this is the details about prompt setting. Now suppose maybe I can tell you few things, like for example 2 to the power 10, maybe 1000. Okay, so see here. So my calculation is coming, like for example suppose I will write 2 to the power 10, it is coming 1024, that is fine. If I'll write maybe 50, okay, it will show me in the uh, this scientific notation. Okay, so this scientific notation sometimes is not clear to me, maybe sometimes it is not clear to you. Okay, now I wanted to get that value exactly how it is. Okay, I don't want the scientific notation. So for that thing, what you need to do, you need to apply some functions, okay, some options. Based on that you can able to get that values exactly without any scientific notation. Okay, so but if sometimes you wanted to present your big value into the scientific notation part, you can present it. But sometimes if you don't want to present your values into the scientific notation part also, you can manage two things. Okay, so first option is called as scientific notation. Okay, you all are know that about this part, what is meant by scientific notation. Maybe I can show you quickly. So if you are writing in this way, like 1.1259 e plus 1 15, okay, what it meant by, right? So this is basically tells you about that 1.12 e to the power 15. Okay, so this is telling you about some scientific notation values, right? Scientific notation. But I don't like basically the scientific notation. Okay, so I can change it. Okay, how I can change it, I will use the options. Okay, there is a very good command options, like here you see the options and you change the prompt. Okay, similarly now I wanted to change its scientific notation part, so I will use called command called as scipen. Okay, scipen command is basically help you out just to get the values without any scientific notation, right? So this is taking two types of values. First is 0 0, and in that way if I will use a 2 to the power 50 now, see here, this is coming in a scientific notation, right? But if I will change this value, okay, how I will change this value, maybe I will change this value 999 and I will run this code again. Now this scientific notation value is converted into the actual numeric values. Okay, I can easily understand these values, right? So this is our real values and this is our scientific notation values. So if you wanted to convert your general values to the scientific notation values, use options scipen is equal to 0. Okay, this is important commands we are learning before starting our actual R studio R programming session. Just because of that we are going to be a data analyst. Okay, we are doing our day-to-day data analysis activities. So sometimes when you are doing data analysis and you are getting values in such notations, so you can understand, you can change those values using this type of commands. For that things we are just, before starting our actual classes, we are just setting up some general formulas. You need to remember those very small steps so that you not stuck into the big programming problems. Okay, now I'm just if you wanted to change the scientific your general notation to the scientific notation, use scipen is equal to 0. And if you wanted to project your scientific notation value into the real values, use scipen is equal to 99. In that way you will handle this particular scientific notation values. Okay, so these are the few ground rule I wanted to set up. Okay, so these things are very important for you. Okay, in the sense that when you are doing your the big programmings, okay, at that time if such kind of things are coming, so no need to worry, you can change those things by using this type of options. Okay, now I am moving to the like for example here so much options, so much details are coming over here, right? So much big things are coming, right? So here since all commands are coming, so it is also taking some memory space. Okay. Now if I wanted to delete or maybe I wanted to delete after some time, okay, so I can also use few commands over here so that I can control into the console part. Okay. So there is a very good option is available into the RStudio, is called as options, and there is a command called max.print. Okay, max.print is equal to 3. So if I will run it, okay, so whatever the things I will write over here, like for example this, and after 3, okay, after 3 prints, okay, after 3 prints it automatically will delete. Okay, after 3 prints automatically it will delete the things, right? So it is not going into the memory. Now our memory is not kind of a storing those whatever the things are coming over here. So memory is already being free because we had applied the options max print is equal to 3. So three things will be stored into the memory, like for example 3 lines will be stored into the memory. Other than the 3 lines, everything will be deleted for the memory. Okay, this will not go into the memory and this will not save at all those things. Okay, so our memory is releasing, right? Now these are the few options you need to remember. Okay, now if anyone have any doubt, maybe you can ask questions. Otherwise let me tell you about some R and its nature of calculating the things. Okay, so like for example R is working as a calculator. R is working as calculator. Okay, this is the one of the important functionality of this particular software is. Okay, so how you can see what are the operations we can perform. So we can perform in R all kind of mathematical operations. Okay, so like for example we can use addition, we can do subtraction, we can do multiplication, we can do division, we can do integer division. Okay, we can do power, we can do square root, we can do logarithmic of anything, we can do exponential. Okay, so whatever the operation we wanted to perform, we can perform into this. Okay, how we will perform? Let's suppose I wanted to sum, like for example 2 plus 2. Okay, so if I wanted to run I wanted to just sum two values, 2 plus 2, I will do that. 2 plus 2 is equal to 4. Okay, see here 2 plus 2 is going to the compiler interpreter, and after running it, it will give me the output as 4, right? Similarly if I wanted to subtract 3 minus 2, okay, 3 minus 2 will give me 3 minus 2 is equal to 1. Okay, so this is giving me 1. So these are the few calculations you can perform. Okay, so like for example 3 into 2, okay, it will give me calculated value 3 to the 6. Similarly if I wanted to divide 3 by 3, it will give me 1. We can calculate the modulo. Okay, we can calculate the modulo is 0, right? Similarly if you wanted to give the power, 2 to the power 2, okay, 2 to the power 2 you can give 2 to the power 2 means 4. Okay, it will give me 4, right? So these are the few very basic mathematical operations we can perform into our R studio, right? So now suppose we are having sometimes you are having some issues like which is called as operator precedence. Operator precedence. Okay, operator precedence. So what it mean by operator precedence? Like for example you are having 3 plus 4 modulo uh, 3 into 4 and plus, okay, plus 6 minus 7, okay, and multiplied by in bracket 6 multiplied by maybe 4 plus 5. Okay, let's suppose this type of values, this type of kind of mathematical combinations you are having, right? Now you wanted to calculate it. Okay, so how you can calculate it? You know that operator precedence. Okay, so operator precedence is having the rule called as Bodmas rule. Okay, so many of you will aware about those things, I know. Okay, BODMAS. So basically BODMAS rules is telling you that firstly it will solve the things which is available into the brackets. Okay, bracket of. Okay, so whatever the things is available into the bracket, it will solve those. Okay, so like for example 4 plus 3 it will give the 7, and 3 4 6 in this way this will solve this. Okay, after that this will solve this. So once the bracket thing will be solved, okay, it will do the division, division. After that it will give the multiplication. After that you will do the addition, and in last you will perform the subtraction. So this is called as BODMAS rule, and this BODMAS rule is just for use for operator precedence. Okay, so now, like for example, if I will run this command, so it will give me the output like 5.727273. Okay, in this way I can able to see this particular output, right? So similarly, okay, similarly you have some fractional fraction or exponentiation we are having. So right, so for example, if you wanted to give any power, right, so if you wanted to give any power like 4 to the power 2, okay, 1 upon 2, okay, square root of 4, you will get 2. Okay, any fractional power you can give here, like for example this one you can give like 0.4. Okay, so you give in this way and you will get the output in this way. Okay, so in any ways you can do the power notation. So power notation can be given into the this symbol, hat symbol. Okay, so this will give you the output as a some power value, right? Now some mathematical functions. What are the mathematical functions are available? Okay, so I'll touch upon few of the things. Okay, and left it for you to explore by your own. Yeah, please go ahead, George.
Okay, thank you. Please, is there a way we can use how to show working in the mathematics that
Sorry.
we just saw? Is there a way we can ask it to show working? As in, for example, the board mass issue. Can we ask it to show working so that we will see the steps, the various steps that it used to arrive at the answer?
Yes, yeah, always you can do, because it is, I'm just telling you that this particular thing is being solved by using the BODMAS concept. Okay, so this is doing by using the operator precedence for sure. Definitely if you solve one bracket at a one time, okay, it will solve in that way only. That, like for example, in this particular bracket you are having three operators: one is multiplication, one is addition, and one is subtraction. So inside this particular bracket this is also following the same concept called BODMAS. So according to the BODMAS rule, what it will do, firstly it will just divide it. Okay, so divide means if any symbol is division is there, no, then multiplication is there. So 3 4 7. Okay, 3 4 4 3 are 12 is there. After 12 it will give 12 plus 6 is equal to 18, and 18 minus 7 11 is there. Okay, so now if I'll run this particular chunk of code, okay, chunk of operation over here, it will give me 11 over there, right? So in that way this will solve basically, right? So this is solving, always follow the concept of BODMAS. Okay, just for kind of giving the preferences to the operators. Okay, now coming to the mathematical part, what are the mathematical functions is available into our R Studio part? So we are having so many established functions, like for example sqrt. Okay, so sqrt function is basically used for giving you the squared values, okay, square root values. So like for example, if I write over here square root of 4, it will give me 2. Okay, similarly if I write over here sqrt of 25, okay, it will give me 5. Okay, so if you wanted to calculate the square root, you can follow two ways. Okay, one is that you can give like a power 1 by 2. Okay, you can give 2 to the power, maybe sorry, 2 to the power 0 0.5, 0 0.5, right? So in by using this way, or maybe using the sqrt functions, in using the sqrt functions of 25. Okay, in these three ways you can do the square root of those numbers, right? Similarly, if you wanted to do, if you wanted to solve the exponential e to the power 2, okay, e to the power 3, e to the power 4. Okay, so you will write here the exponential. Okay, in the exponential, whatever the things you will write, it will calculate the exponential form of this, right? Similarly exponential of 20, right, exponential of 20, so it will calculate and give me the output, right? Similarly you have kind of a log functions. Okay, you can use the log functions and you will get the values. Like for example log 10, it will give me the value log 10. You will get the value of log 2. Okay, if any value you wanted to get, you can specify log and you will write the value and you will get the result of this log transformed values, right? In log we need to remember two things. In general log functions we have two things. One is called as the actual value on which you wanted to calculate the log, and which base you wanted to use. Okay, so log is coming with two things. One is called as value. Okay, one is called as value, another is called as base. Okay, so which base you are having? So let's suppose you are having the value 10. Okay, and if the base is equal to 10 as well, then log base 10, log 10 base 10 is equal to 1. Okay, this is 1. If I will use the base is equal to 2, then it will have the value like 3.332. Okay, so since base is matter a lot over here, so whenever you are using any log functions, you need to remember, you need to aware about that which type of base you are using. So right now I am using different ways, like for example base 2. Okay, if I use simple log 10 over here, so it will give me natural log. You know that definitely, definitely most of you is quite aware about different types of log notations. So this basically things is called as natural log, and this log is called as log base 2. Okay, similarly if I change it by using log 10, so this is called as log base 10. Okay, so these are the few functions you need to remember it, right? And after that, few functions like for example absolute value giving function is there. So absolute value is like whatever the value you are passing into this, like absolute of -56, it will give me back to actual value of 56. Okay, similarly you are having like pi is a established value like called 22 by 7, 22 by 7, right? So it will give me 3.141593. Okay, so pi is a fixed set of values over here. Okay, so this is values, what is the value? This is basically 22 by 7. Okay, so this is a unique value, this is being already assigned. Okay, so pi is coming like here 3 point, and basically this is coming up some rounding values. Okay, that is why this is coming in a different ways. Okay, those two values are almost same. Okay, this is basically a pi notations. Similarly, if you wanted to use sine function, okay, you can use it. Okay, if you wanted to use the cosine function, okay, cosine function, you can use this cos. Okay, you can write the things over here. Okay, similarly if you wanted to use some other things, like for example you are having the values like 2.45678. Okay, let's suppose you are having this. Now you wanted to round those values. Okay, now you can round those values very easily. Okay, so you can write the round over here, and you just type the values over here like 456 in that way, and how many values you want. Okay, you need to specify the digits. You need to specify the digits, like for example I wanted only two values. Okay, after decimal I wanted to have two values, so I will round it up to two values. Like for example, see here, it is coming 2.35. Okay, so these are the few basic functions what we have covered in our today's class. Okay, so this is all about today's class. In our next class I will touch base upon the simple variables declaration part, how you will declare the variables. Okay, and how you will play, how you will create the different types of variables. Okay, and what are the different symbols which we are using in our R Studio programming. Okay, till today what we have seen that what are the introduction of different types of windows over here, what the windows you are seeing over there. Okay, other than this you saw that R is basically performing as a calculator. You can perform your all the calculator activities into this particular software in this way. Okay, along with that you have a very rich function available into this particular R Studio software. Like for example log is there, exponential is there, pi is there, sine, cos, tan is there. Okay, any kind of mathematical formula is easily being solved by using this particular programming language. Okay, so this is all about today's class.